Then you understood what is gravitation. It's a force between any two bodies in the universe. You understood what is the gravity. It's a force with which the earth is attracting any body. Then you understood what is acceleration due to gravity. It's the acceleration of any body which is falling purely under the gravity, which is free fall. It's having a free fall. Then is Newton's law of gravitation, where you have a mass m1 and m2. Record pannrela? When m1 and m2, the force separation between them is r. Supposing then the force of attraction is m1 into m2, directly proportional to product of masses inversely proportional to square of the distance between them. F is equal to g into m1 m2 by r square, where g is a gravitational constant, which is 6.67 10 to the power minus 11 Newton meter square per kg square. But having said that, we have to do this in vector form. To do it in vector form, let's consider m1 and m2 here. You know that the first body is going to be attracted by the second body in this direction. Yes, and the second body is going to be attracted by the first body, which is F21, which is in this direction. It's just a vector, okay, in this direction and this in this direction. The distances are measured. The position vector is R12. It's measured from 2 to 1, and this is this distance R12, which is in this direction, and R21 is measured in this direction. F21 will have R21, F12 will have the distance measured from R12. Okay. Yeah, I'm recording. So then therefore let's write what is F12. F12 vector is capital G into M1 M2 by R12 vector the whole square. The moment you square a vector, it will become a scalar. So you have to write R12 cap to indicate that there is a vector, it is a vector. Just a cap there. Similarly, F21 vector, it is capital G into M1 M2 by R21 vector the whole square. Again, when you square the denominator, you have to write R21 cap. And you know R12 cap is minus of R21 cap. Distances are measured in different direction. Therefore, F12 vector, they both are the same, only the direction is changing. Is minus of F21 vector. Thus, they are attractive in nature. This is how we write in vector form. They ask you in vector form, Coulomb's law, you have to write it like this. Nothing else. Okay. So then next is principle of superposition. In the gravitational force, there is something called superposition of gravitational force. Superposition of gravitational forces. Do you have it? They didn't ask you this. Okay, then leave it like that. Okay. Superposition is number of masses are there, not just 2 masses. We just dealt with 2 masses, right? Yes. There are 3 masses and 4 masses. You don't have it? Okay, so then let's forget about it. Next is shell theorem. Very, very important shell theorem. They would have taught you in school. Okay, so you are talking about the shell. Shell in a muttayoda egg matram. There's no yolk inside. Just think egg alone. That's a shell. It's hollow inside. So let's draw a shell. I'm drawing it like a ring, but it's not a ring. It is actually a shell, spherical shell. Take a hollow. This is a shell. When you say shell, it means it's hollow, and it's spherical. Okay, let's this radius is r and this mass is m. Let's consider a point P where there's a small m, which is situated at a distance of r. A small mass is situated at. So, a periya mass and one small mass separated by distance of small r. Force of attraction is capital G into capital M small m by r square. But what happens if the point P is going to be lying on the surface? Then small r will become equal to capital R. And therefore, the formula would change as F is equal to G into capital M small m by capital R square. Yeah, what happens if this we are talking about a shell? What happens if it's a homogeneous sphere? A homogeneous sphere means it's like earth crust or our head, which has got brain inside it. Earth crust has got earth. It's not hollow. Basically, it's not hollow. So homogeneous solid sphere, which means this mass is evenly distributed. So for this is mass m and this is capital R. Supposing I am talking about a small m situated at a point P, which is at a distance of small r from the center. You know, again the force of attraction will be G is equal to G into capital M small m by small r square, and this point is going to be on the surface. Small r is equal to capital R, F is equal to G capital M small m by r square. There is nothing special whether it's hollow or solid. It's behaving the same way if the mass is outside. No difference. But when the mass is interior, that is when the shell theorem becomes very important. Now take a solid shell, solid sphere. Shell use pannakoodadhu. Shell nale empty. So take a solid homogeneous sphere of mass m and radius r. Consider a point P in which there is a small m situated. This is at a distance of small r. It's present in the interior. there is a force of attraction which is provided by the earth, whose mass is situated only interior to the small earth. The force of உனக்கு வெளியே இருக்கிறது உன்னை பாதிக்காது, உனக்கு உள்ள இருக்கிறது தான் பாதிக்கும். This is you. What is interior to you? The mass of the earth which is present interior to the point mass is what is going to cause the force of attraction. So G into mr into small m by r square, where mr is the mass of the earth which is interior to the point mass, is going to cause the force of attraction because it has to attract the small m, right? So this is mr. So this is how it changes. Okay, but if it's suppose this is for a solid homogeneous, so homogeneous solid sphere, homogeneous solid sphere, correct? But if it's hollow and it's smaller, m is situated distance is smaller from the center, this capital R and this capital M, the small m will be attracted in all directions and the net force experienced by this body will be 0. If it is hollow and a small m is situated inside, the net force experienced by it will become 0. Next question is gravitational shielding possible? Gravitational shielding. Shielding means protecting it from any other attractive force. Okay. So supposing in next year we learn about charges. You take a positive charge and put it inside a Faraday's, it is a cage, okay. You put it inside this and close it. This charge will not be attracted by any other charge. You are able to isolate this charge by placing it inside a Faraday's cage. It's possible only if it's a charge. But if you put a mass inside and close it, if I lock Ritanya inside, still she will find a way to contact Ritika. Correct? She will find her own way. So then you cannot do gravitational shielding. By placing a mass inside a hollow sphere, you cannot protect it from being attracted from any other body. It will still be attracted by every other body. Correct? இப்போ நீ போயிட்டு ஒரு ஷெல்லுக்குள்ள போய் உட்கார்ந்தா will not be getting pulled by the gravity. You still will be, the box will also fall down, right? So then it's not possible to do gravitational shielding. Electrostatic shielding is possible. You can put a charge inside and shield it from, but not in the case of, அப்படினா என்ன மூணு எடுத்து இப்படி போட்டீனா entire world planet எடுத்து போட்டீனா collapse ஆயிடும். So you cannot do gravitational shielding. You cannot put it inside a hollow shell even though the force inside is 0. You cannot stop it from being attracted by the external bodies. Are you clear? So that's about electrostatic shielding. It's about gravitational shielding. Now it's gravity on the surface of the earth. Expression for G on the surface of earth. Okay, consider this is earth of mass m, this is r. Supposing a body is present on the surface of the earth, small m. Okay, and you know that the force of attraction is G capital M small m by capital R square, which is also equal to m into G. The force with which earth is going to attract it. M and m get cancelled. Thus, you get the gravity on the surface of the earth is Gm by R square. This is the equation that I was talking about. Okay. Supposing gravity, from this we also can cross multiply and find Gr square is equal to Gm. Instead of Gm, you can always write Gr square. The second equation. Now, supposing the body is present at a height h, and this is radius r. Supposing the body is not at the surface of the earth, it's at a height h, like you are on the third floor. Yeah, then the total distance will become r plus h. The force of attraction will be capital G into capital M into small m by r plus h the whole square, which is equal to m into G at a particular height. Mg will not be mg, mg at a particular height. So m and m will get cancelled. Gravity at a particular height is Gm by r plus h the whole square, correct? And you know small gm can be replaced as Gr square. Yeah, so then therefore it's r plus h the whole square. This is the formula. But if h is small, you can write r square, you can take r square out, right? 1 plus h by r the whole square, where r square get cancelled. You can take this up exponents as minus 2 and do binomial theorem. To do a binomial theorem, it will become 1 minus 2h by r. 1 plus x the whole to the power minus n is 1 minus nx. 1 plus x the whole to the power n is 1 plus nx and so on. This is what is binomial theorem, basic thing. So the 2 comes here and becomes minus 1 minus 2h by r. So this is another formula. What are the formulas? This is equation 2. This is equation 3. This is formula number 4. This is gravity at a particular height. Therefore, you understand that height is going on increasing. The 1 minus will decrease, and so gravity at a height is also decreasing. So as you go above the surface of the earth, gravity keeps on decreasing. Next is gravity at a particular depth. So this is radius r. Gravity at a particular, supposing there is a point mass m situated at a distance of depth d from the surface of the earth, then this gap will be r minus d. Correct? This gap from the center is r, distance is measured only from the center, so r minus d. As I told you in shell theorem, only the mass which is interior to the point mass is going to contribute, mr is going to contribute to force of attraction. So F is equal to capital G into mr into small m by r minus d the whole square, which is equal to m into g at a particular depth. So m and m get cancelled, g at a particular depth is g into mr by r minus d. But to find mr, let's find mr, mass of the part which is interior to small mass. So for which you should know, like 20 apple ivlo ruvana, 60 apple ivlo ruva, unitary method. Capital M is the mass of the earth, capital M is the mass of the earth for a volume 4 by 3 pi capital R cube. What will be the mass of the earth for 4 by 3 pi r minus d the whole cube for the kutti part? So when you cross multiply, this gets cancelled, mr itself is m into r minus d the whole cube by r cube. Substituting that here, a GD is equal to G into m into r minus d the whole cube by r cube into r minus d. The r minus d will become square. And you can write Gm as small g r square. GD is equal to small g into r square into r minus d the whole cube by r cube. R square and r cube get cancelled. Gr square and this is r cube. So you get a formula. This is r minus d, something I made a mistake. Gmr by r minus dd. Gd is r minus dd whole square. Whole square with correct? So whole square now, this will become r minus d only when you cancel, correct? Okay, let me do it again so that you get clarity. You know, therefore GD itself from this equation is G capital Mr by r minus dd whole square. To find mr, you are using this unitary method and you are finding like this, substituting there, GD is equal to G into m into r minus d the whole cube by r cube into r minus d the whole square, where this and this get cancelled. Gm can be written as gr square, small g into r square into r minus d by r cube. This and this get cancelled, correct? So you get GD to be G into r minus d by r. This is one formula, this is equation number 5. You can also write GD to be G into 1 minus d by r, which is equation number 6. This is gravity at a particular depth. Your mom has come, no? No. Okay, this is gravity at a particular depth. After then as you know, as d increases, 1 minus keeps on decreasing. So gravity at a depth is also decreasing. So as you go deep into the earth, gravity is decreasing. As you go higher above the surface of the earth, also gravity is decreasing. There is one point when the gravity is equal. Gravity at a particular height and gravity at a particular depth are equal. What is gravity at a particular height? Is G into 1 minus 2h by r. Gravity at a particular depth is G into 1 minus d by r. G get cancelled, 1 get cancelled, 2h by r is equal to d by r get cancelled, 2h is equal to d. Therefore, if you go 4 kilometers depth, 8 kilometers you have to climb above, so that the gravity will be same. Okay, next case study, another case study is consider d is equal to r. That is the entire depth is becoming equal to radius, which means at the center of the earth. R, it will become GD is equal to G into 1 minus r by r, which is 1. And therefore GD is, the gravity at the center of the earth is 0. So you will feel weightless at the center of the earth. Are you clear? Because gravity is not there. Okay, so next is shell theorem. I finished gravity at a particular depth, gravity also changes according to shape of the earth. Okay, now I taught you one diagram, no? This diagram is very important, this graph. Yeah, the gravity is directly proportional. You know, as and it comes like this because, you know, when as the depth is increasing, as the depth is increasing, the gravity is decreasing. It's inversely proportional. But we are not doing a graph between gravity and depth. We are doing gravity and r. R is the distance from the origin. So when the depth is increasing, r is decreasing and gravity is also decreasing. So R decreases, gravity decreases. So that's directly proportional. That G is directly proportional to R. Whereas outside the Earth's surface, it's inversely proportional to R square. R square, right? G is equal to G capital M by R square, which shows that G is inversely proportional to R square. So outside the Earth's surface it's like this. Inside of the Earth's surface it's like this. So this graph is very, very important. After that, I want to teach you how does the gravity change with the shape of the Earth. G changing with the shape of Earth. Okay, suppose you have Earth like this, it's flattened, the Earth is like this, not exactly spherical. This is equatorial, so this is radius of the Earth. This is poles of that, and this is poles, so radius of the pole. And the gravity is inversely proportional to radius, square in fact. So you can write it as gravity on the poles is inversely proportional to radius of the poles, and gravity on the equator is inversely proportional to radius of the equator, the whole square. Radius of the equator is always greater than the radius of the pole. So this is greater, so gravity will be lesser. This will be lesser, so gravity will be greater. So then therefore gravity is greater at the poles than at the equator. Gravity at the poles is much greater than the gravity at the equator. So a person will be measuring less at the equator than at the poles. அதனால ஈக்குவேட்டர்ல வந்து கோல்டு வாங்கிட்டு போனா அங்க போனா ஹெவியா இருக்குமானா அதெல்லாம் கிடையாது. But having said that, that's some joke that I need tracking for some more reason. So then let's go to next. How does the gravity change with latitude? What is the meaning of latitude? Latitude is always an angle. Okay, so then suppose this is the Earth. Now I am drawing it spherical. A point P on the surface of the Earth, join it with the center of the Earth. This is any point on the surface of the Earth and the center of the Earth makes an angle lambda with the equatorial plane. That is what is called, this lambda is what is called latitude. Latitude is the angle made by the point on the Earth and the center of the Earth making with the equatorial plane. The line joining the point of the Earth and the center of the Earth is going to make with the equatorial plane is lambda, which is known as latitude. Okay. As the Earth is spinning, this point P, this derivation is not important, but you should know it. Earth is going to spin and it spins, the point P is going to move like this, rotate like this. This distance is smaller, whereas this distance is capital R, radius. You can construct this into right triangle, write this as smaller, and from this right triangle, cos lambda is equal to small r by capital R, small r is equal to r cos lambda. Correct? You know that if supposing you are the person who is sitting in this latitude, you will be attracted to the center of the Earth by force mg, obviously. And there will be a normal reaction. And since this is r, this will be mr omega square, and this will be lambda. This is lambda, interior alternate angle, this is lambda, vertically opposite angle, this is lambda. So it's mr omega square cos lambda, and this will be mr omega square sin lambda. Therefore, can you see this minus this, mg minus mr omega square cos lambda will give you m into g lambda, the gravity at a particular latitude. M throughout gets cancelled. G minus r omega square cos lambda is equal to g lambda. Small r itself is capital R into cos lambda minus capital R into omega square cos square lambda. When you substitute, you will get like this. And this is the formula which I used to justify when the gravity will be maximum. Gravity will be, I think gravity will be minimum only when this is maximum, for which cos lambda has to be equal to 1. Therefore, lambda has to be 0. So, at the equator is when the gravity is minimum. Something like that. Okay. So, then next is what did we do after that? Gravity at a particular latitude is over. Then is escape velocity, orbital velocity. Oh, gravitational potential energy. Yeah, exactly. So, next is the gravitational potential energy. Sorry about my bad handwriting, but you can follow it from my notes. Gravitational potential energy, supposing there is a body, supposing there is an Earth whose radius is r. I am bringing a body from infinity into the gravitational field of the Earth. I am bringing it from infinity to a point P, which is at a distance of always r. I am bringing a body mass m to a point P which is situated at a point. What is the work done in bringing it from infinity to this point is what is known as gravitational potential energy. Gravitational potential energy is the work done bringing a body from infinity to a point in the gravitational field of another body. Correct? So, I am taking Earth here as one body and bringing a mass m. So, for which I have to consider randomly this is A and this is B. And this A is at the distance of x. and is AB is at a distance of dx. If you don't write this, you can't derive it. And potential energy is nothing but work done. Work done is equal to force into displacement. dW is equal to F into dx. F itself is G capital M small m by x square here, because we are talking about at a point A. It's x square into dx is what is dW. So integrating both sides, you get a G capital M small m or constants 1 by x square into dx on integration becomes minus 1 by x. Why? Because 1 by x square, integration of it is x to the power minus 2, and x to the power n itself is x to the power n plus 1 by n plus 1. Therefore, it becomes x to the power minus 2 plus 1 by minus 2 plus 1, which is x to the power minus 1 by minus 1, which is minus 1 by x. Therefore, you get the integration of 1 by x square to be minus 1 by x. Integrated from infinity to r. You are bringing it from infinity to r, this r here, yeah, infinity to r. So, it is from infinity to r. Upper limit minus lower limit is minus 1 by r plus 1 by infinity. 1 by infinity is 0, upper limit minus lower limit. It will become minus G capital M small m by r will be the gravitational potential energy. Yeah, why is it negative? Because the potential energy is negative because we are doing work against the gravitational field. We are doing work against the gravitational field and bringing it inside, or in other words, I can also say it's an what is involved is an attractive force here. Sorry, let's say this as an explanation. Since the force involved is attractive, the energy will also be having a negative sign, just indicate that. That is a better explanation. Okay, so then next is of escape velocity. Escape velocity. Something has to escape from the gravitational pull of the earth. Force of attraction in it has to escape so that it goes into space. So G capital M small m by r square, supposing it is escaping from a small r, it has to escape from small r, not from the radius of the earth. It has to escape from the entire into space, which will be equal to G capital M small m by r square is equal to, escape, it has to escape, it has to have kinetic energy. It has to have that much kinetic energy to overcome the force of attraction. Now I have a doubt whether to put a small r square or a capital R square. I want to see that once, okay, so that we are not making any mistake there. So it's escape velocity, where it's escaping from gm, okay, by g, but why should there be an r square here? It's not force, it's kinetic energy, which means you are going to equate it to potential energy, which is G capital M small m by r. You have to equate the kinetic energy with G capital M small m by r. So small m and small m get cancelled. So VE itself is root 2gm by r with the root. And since gm is equal to gr square, it will be root of 2gr square by r. So it will become root of 2gr. That will be the formula for escape velocity. So what did I forget? You have to write G capital M small m by r. Potential energy has to be equated to kinetic energy. That's the key. I am forgetting that. Don't forget that. Okay, it's not the force. Okay, in next case, that's you get the escape velocity. For orbital velocity, for orbiting around that, here centripetal force mv square by r will be equal to, this is the force, I have to equate to force of attraction, which is G capital M small m by r square. Here only I can equate force with force. There I am equating potential energy with kinetic energy. That's the key. Okay, if you forget that, gone. We will not be able to write that. So then here it is r plus h. So ideally it will be r plus h, right? mv square by r plus h with gmm by r square by r plus h the whole square. Because r is not r plus h. So r plus h and r plus h whole square will get cancelled. Hence we can write an expression for VE square, which is g, n and m get cancelled, gm by r plus h. So VE itself is root of gm by r plus gm by r plus h. You know gm is equal to gr square. So substituting that here, VE is equal to root of gr square by r plus h. Correct? Into this m is also coming. No, gm is gr square. So can you see r square can be taken out? It is g by r plus h. It's escape velocity. Yeah, you can do like this. Now supposing, you can also consider that h is negligible when compared to r. H is negligible when compared to r. But you should know that it is. because the satellite is not launched so high. Radius of the earth is anyway much larger. So h is negligible when compared to r, so h can be ignored. In this, let's ignore h. So you get a root of gr square by r. So r and r becomes the root of gr will be escape velocity. You know orbital velocity is so this is orbital velocity. Sorry, what did I do? All this is orbital velocity, and you know escape velocity is root 2 times orbital velocity because there is a root 2 gr there. So that is the conclusion. So that's what is this part, and then next is that's all is the entire lesson. And then Kepler's law. What are the 3 laws of Kepler? Kepler's law, first law states it's known as law of orbit. Law of orbit. What is law of orbit? Is so you know that Earth is flattened at the poles, and it's like this, right? It covers equal distance. It covers equal area and equal interval time. No. Okay. The first theorem is law of orbit. According to the planet revolves around the sun at one of its foci. There will be 2 foci, one here, another here. An ellipse will have 2 focuses, right? This is one focus and this. So the planet always revolves around the sun with sun at one of its foci. This is the first law. Okay. And there is something called perihelion aphelion. The point P, which is closest to the sun, this distance is called perihelion, and the point B, which is farther away from sun, is called aphelion. So you have a perihelion and an aphelion, which means radius is not the same. The radius is going to be differing. So that's the first law. Second law is law of areas. So you have an ellipse like this. This will have a bigger radius, and this will have a smaller radius. A small radius will obviously have greater velocity. Greater velocity. So therefore, this area, but this area and this area are the same. The arc length is more because the linear velocity is more. Linear velocity of this is greater than linear velocity here. But the angular velocity is the same. Omega. Angular velocity is all same. That is, what to say, angular velocity is theta is equal, angular velocity is omega is equal to theta by t. Angular displacement by time will be the same. Angular velocity is always equal. But the linear velocity differs. Therefore, the arc length, supposing this is AB and this is CD, the arc length of AB is greater than arc length of CD. But however, the areas inside are the same. Areas inside is same time, supposing it takes the same time. Therefore, the planet covers equal area in equal interval of time. In equal interval of time, irrespective of whether it's in the perihelion or in the aphelion. That is your second law, law of areas. The radius vector always subtends equal areas in equal interval of time, irrespective of whatever the position of the planet is. Are you clear? So then the third law is law of periods. Law of periods, which I told you. T1 square by T2 square is equal to R1 cube by R2 cube. We just saw a relationship. The square of the time period is proportional to the cube of the radius. How did Ashika told us to do that? She told us to do mv square by r. mv square by r is equal to g capital M small m by r square force, because you could r and r get cancelled. Instead of v, you can write 2 pi r by t. M is equal to 4 pi square r square by capital T is equal to g capital M small m by r. So then therefore by cross multiplying, capital T small m gets cancelled. T g m 4 pi square r cube. So you can find the mass of any planet by using 4 pi square r cube by Tg. You get a formula to find the mass of the planet. You also get that this is This is one equation for one planet. Then you can write another equation. This is T1 with R1. Another equation T2 Gm, okay, 4 pi square R2 cube. So then therefore you get a T1 by T2. Therefore these are proportional, right? Can you see? Therefore T1 is proportional to R1 cube and T2 is proportional to R2 cube. Therefore T1 square at T square, because velocity is 2 pi r by T. There has to be a T square. I forgot the T square. Making mistakes after mistake because I'm rushing through. Are you clear?